Welcome to this explainer. Let's just dive right in. Imagine you're building a massive skyscraper. You wouldn't just hand a crew a bunch of steel and concrete and say, hey, go have at it, right? No way. You would need a blueprint. Well, in the world of data engineering, skipping that blueprint is a guaranteed recipe for project failure. Getting your data modeling right isn't just some boring technical requirement. It's absolutely crucial. It's the highest stakes game for actually aligning your business needs with your technology. So today, we're going to completely demystify data modeling. We'll walk through its 3 distinct phases, and we're going to uncover 10 incredibly costly pitfalls that routinely completely derail data projects.
To kind of ground us before we start, listen to this quote from Joe Reyes, the co-author of Fundamentals of Data Engineering. He describes data modeling as organizing and standardizing data to facilitate believable and useful information and knowledge for humans and machines. What's really fascinating here is that dual nature of the job. You aren't just writing code for a server, you're acting as the vital bridge between human business needs and machine execution. Because think about it, if the humans don't trust the information, or the machines literally can't process it, the whole model has failed.
So what exactly is data modeling? Formally, it's the process of creating a visual representation of an information system. It's how we actually communicate connections, structures, entities, and all that vital business context. Think of it exactly like that architectural blueprint we just talked about. Before a single line of database code is written, before we pour the digital concrete, we have to map out exactly what elements exist and how they relate to one another.
Here is our agenda for the explainer. First, what is data modeling? Second, Phase 1, conceptual modeling. Third, Phase 2, logical modeling. Fourth, Phase 3, physical modeling. And fifth, the ultimate modeling mistake.
Okay, starting with Section 1, what is data modeling? The life cycle blueprint.
Data models are essentially broken down into 3 distinct sequential steps, and they build up from abstract ideas to concrete structures. Step 1 is the conceptual phase. That's your high-level abstract representation. Step 2 is the logical phase, your detailed blueprint. And Step 3 is the physical phase, the actual technology-specific structure. Now, you absolutely cannot skip these steps without inviting total disaster, and you'll see exactly why in a minute.
Let's move into Phase 1, conceptual modeling, the rough sketch. Right off the bat, at this first stage, we are completely technology agnostic. No SQL, no database constraints, literally no complex software at all. This phase is entirely about focusing on key entities and relationships to create a shared understanding with your business teams. It's a super high-level, abstract representation of what the organization actually uses every single day. The whole point here is to foster debate and establish crystal-clear communication before anyone starts building anything.
But man, this is where the danger starts. Let's unpack the first 3 critical missteps. Mistake number 1, starting too late. If you rush right into detailed design without this conceptual map, you're going to end up with massive rework because your data structures just won't align with what the business actually needs. Mistake 2, insufficient stakeholders. If you don't get the right people in the room, you miss critical requirements. And even worse, you generate cultural resistance. People simply won't use a system they didn't help shape. And mistake 3, lack of clarity. If you don't clearly define your entities now, those little misunderstandings compound into massive data inconsistencies later on. The cost of rushing past this conceptual phase is frankly enormous.
Next up is Phase 2, logical modeling, the blueprint.
Once we have that solid, agreed-upon sketch from Phase 1, we get a bit more refined. Now, notice that this model is still platform-independent. We still do not care if you're using Oracle, Postgres, or some NoSQL database, but we are defining the semantic layer in sharp detail. We're explicitly mapping out the specific attributes of each entity, the keys, and the exact cardinality of all those relationships. This serves as the rock-solid foundation for the eventual database, giving everyone a vital visual understanding.
And that brings us to our Phase 2 can really fall apart. Let's look at mistakes 4, 5, and 6. Mistake 4, inconsistent naming patterns. I know it sounds trivial, but messy naming causes profound confusion, and that leads directly to data mapping and integration errors. Mistake 5, incorrect granularity. If your model is too simplistic, it just misses essential info. But if it's too complex, your development time and costs are going to absolutely skyrocket. And mistake 6, ignoring application usage. If you don't design for how the applications will actually be using the data in the real world, you end up with brutal performance issues and a model that totally fails to support business operations.
Now for Phase 3, physical modeling, the construction. We have finally arrived at the technology-specific level. Our theoretical design is now officially meeting actual storage. This is where your developers create the exact schema for the database management system. We're defining the tables, the columns, data types, constraints, and we are focusing heavily on performance improvements and storage considerations.
So, the absolutely crucial point here is understanding the mechanics of your specific technology, which brings us to mistake 7, not separating keys from indexes. Keys are what establish identity and relationships between your data points. Indexes, however, are strictly there to optimize your data retrieval times. Confusing these two in your physical model is a recipe for disastrously slow retrieval times, totally bloated storage requirements, and terrible overall performance.
Moving on to our next physical phase pitfalls, let's unpack mistakes 8 and 9. Mistake 8 is rigidly mapping user interfaces to data fields. UIs change constantly, right? If your physical database is rigidly tied to one specific interface, it becomes completely inflexible when business needs inevitably change. Mistake 9 is failing to plan for data model evolution. Look, concrete shouldn't mean rigid. If you don't consider future growth, your data structure simply won't scale. This forces massive rework and introduces serious data integrity issues down the road.
And finally, Section 5, the ultimate modeling mistake: mixing the phases.
Let's talk about tools for a second. Think about conceptual tools, whiteboards, sticky notes, really simple collaboration methods. Now compare those with physical tools, entity relationship diagrams or ERDs, and complex UML tools. These tools exist for entirely different purposes. And that leads us to the big one. Mistake 10, muddling the models. The temptation is just incredibly strong for technical teams to open up an ERD tool right away, to start describing a conceptual model to stakeholders. But an ERD is already well on its way to a logical or physical model. Using these complex, highly structured tools for the initial conceptual design totally skips the fluid experimentation stage. You end up freezing your designs way too early, long before you've actually aligned with stakeholders on what the business truly needs.
To really drive this point home, consider this powerful insight from data expert Kurt Kogel. He says, a conceptual model needs to be fluid, needs to allow for input, and most importantly, needs to provide a basis for experimentation. You literally have to put together use cases and see what breaks on a whiteboard. Why? Because as he notes, changing a design at the logical stage is hard. Changing it at the physical stage, where you have explicit links and dependencies written in code, is much, much harder still.
You absolutely have to focus on the process before jumping into the build. So, as we wrap up this explainer, I want to leave you with a provocative question to take back to your teams. Are you testing fluid ideas with your stakeholders using sticky notes and whiteboards, or are you just freezing boxes into a complex diagram way too early? Because getting this right is the difference between a system that scales gracefully and one that completely collapses under its own rigidity. Thanks so much for joining me on this explainer, and I'll see you next time.